All right, this is problem 7.61. We have a force that has a functional dependence on position x. It goes as the square root of x in the I hat direction. This is a constant a. Initially, the velocity is equal to 0, and we're being asked to figure out what the velocity is at any position, in the future, I guess. The theory we can use here is the conservation of energy. Initial kinetic plus initial potential plus work equals final kinetic plus final potential. The work, this right here, is the integral of f dot dx. This is really a one-dimensional problem, so this dot product just becomes f dx like that. The kinetic energy is 0 initially because it's at rest. This right here is going to give us what we're looking for. It's got the velocity in it. There's really no potential to speak of in this problem. It's doesn't talk about gravity or springs or anything like that, so it's only under the influence of that one force, which we'll handle in the work integral here. So a comes out because it's a constant, 0 to x for our limits of integration. We can write x squared as x to the 1/2. That gives us, when we do the integral, remember that you go, take the exponential and you add 1 to it, so that becomes 3/2. So it's n plus 1 over n plus 1, x to the n plus 1 over n plus 1. The a comes down here. Oh, I forgot to evaluate it at its limits, 0 to x. That's my son playing his instrument, sorry. And so if you put the 0 in there, that becomes 0 for that term. And then if you solve for velocity, you get this. In the back of the book, it's a little bit different because they took the square root of 4 and got 2. And they took the square root of x to the 3/2 and got x to the 3/4. All right, hope that helps.